In this video, we're going to take a look at the double angle formulas, which are included on the formula sheet for the final exam. And one thing I want to point out to you is that there are three different formulas for the cosine of the double angle. And you can choose which one you want to use based upon the problem. And I'm going to try to show you that in this first example. Okay, so the first example says, if cosine theta equals -2 square root 5 all over 5, and theta is in quadrant 2, find the cosine of 2 theta. So again, as I'm thinking about this particular problem, and again, I'm thinking about my cosine formulas. Okay, and I'm going to write those up here at the top because I want to kind of make a point here. You have the cosine of 2 theta. We could use the formula cosine squared theta minus sine squared theta. Or I could use the formula 1 minus 2 sine squared theta. Or I could use 2 cosine squared theta minus 1. And I want to carefully choose which one of these problems or which one of these formulas I want to use. So if I think about what information I've been given cosine theta. So I can use that information in the first version or in the last version. I noticed that in this last version, 2 cosine squared theta minus 1, I don't need anything else. I can simply do a plug and chug into that formula to find the answer for cosine 2 theta. So I'm going to use that formula. That it just makes sense. That's the easiest one to use. So cosine 2 theta is 2 times -2 square root 5 over 5 squared minus 1. Okay, so then I need to do the math. We need to square the 2 square root 5 over 5. And so that really means we're doing literally 2 times -2 square root 5 over 5 times -2 square root 5 over 5 minus 1 whole. Okay, remember this 2 is over 1. So I'm going to do all the multiplication kind of straight across there. When you multiply all the numerators together, multiply all the denominators together. So I have 2 times -2, which would be -4, times -2 is going to give me +8. Square root 5 times square root 5 is the square root of 25 over 1 times 5 is 5 times 5 is 25. If I simplify that, I have 8 times the square root of 25 is 5 all over 25. Oops, I'm sorry, I forgot the minus 1 there, didn't I? Minus 1. Don't lose that piece like I did, okay, because otherwise you'll get the wrong answer. Okay, so we have 8 times 5 is 40. So we're going to have 40 over 25. So I've got 40 over 25 minus 1 whole. Again, remember, in order to subtract fractions, we need that common denominator, which would be 25. So we've got 40 over 25 minus 25 over 25. So we keep the denominator, which is 25. We subtract 40 minus 25 is 15. And then I can simplify that fraction. 15 over 25 can both divide by 5. So 15 divided by 5 is 3. 25 divided by 5 is 5. So my answer here in this problem is that the cosine of 2 theta is equal to 3/5. Now, we probably need to think about whether it should be positive or negative. Theta was in quadrant 2. If we double it, I would think that we would be in quadrant 4, which means the cosine is going to be positive. Okay, moving on to the next one, we have if sine of theta is 3 square root 10 over 10, and theta is in quadrant 2, find the sine of 2 theta. So if we go out and look, there's really only one formula for sine of the double angle, and it's 2 times the sine times the cosine. So my formula here is there's only one for sine. The sine of 2 theta is going to be 2 times the sine of theta times the cosine of theta. So if I think about the information that I've been given, I was given the value of sine theta. But in order to finish the problem, I need cosine theta. So in this scenario, I want to take a look at my right triangle. Okay, so I'm going to draw a picture. It tells me that theta is in quadrant 2. Okay, so somewhere in quadrant 2, I'm going to have angle theta. And I'm going to draw in the right triangle. Let me get my... Okay. Remember that the sine of theta is opposite over hypotenuse. So in this scenario, my hypotenuse is a value of 10. The side opposite is 3 on the square root of 10. And I need to figure out the value for the adjacent, which would be my x value. We do that using Pythagorean theorem. So we have x squared x squared plus 3 square root 10 squared equals 10 squared. So I have x squared plus 3 times 3 is 9. Square root of 10 squared would be 10. So that's 90 equals 10 squared, which is 100. Subtract 90 from either side. X squared is 10. And when I square root both sides to solve for x, okay, noting it could be positive or negative, x is positive or negative square root 10. Since I'm in quadrant 2, that tells me that the x value is negative 10. And so now that I've found all of the pieces of my triangle, I can also determine that the cosine of theta, which is the adjacent over the hypotenuse, is negative square root 10 over 10. So now I have the cosine of theta, which is what I need for the formula. Okay, so I'm going to plug into my double angle formula. And the formula again is the sine of 2 theta is 2 times the sine of theta times the cosine of theta. So I have 2 times sine of theta was given to me originally. That's 3 square root 10 over 10. The cosine we determined to be negative square root 10 over 10. Now remember, your 2 is over 1. So here again, we have several fractions that need to be multiplied together. I'm going to multiply the numerators. 2 times 3 is 6 times negative 1 is negative 6. Square root 10 times square root 10 is square root of 100. 1 times 10 times 10 is 100. So I have negative 6. Square root of 100 is 10. So I have negative 6 times 10 over 100, which is negative 60 over 100. I can simplify that. It becomes negative 6/10. And I can go further. It becomes negative 3/5. So ultimately, the sine of 2 theta for this particular problem is negative 3/5. Okay, guys, it's just a lot of plugging into the formula, a lot of algebra or basic math computations that you have to remember when you're dealing with the double angle formulas. You use probably the double angle formulas more so than the half angle, especially in calculus.